Hey everybody, welcome to question 5 of our paper 2 exam series. The exam paper comes if you've just joined us. We're using the DBE November 2023 paper 2 exam. It's really easy to download off their website, and it's always great to do past papers before you write your final exam. Sort of gives you an idea of the structure of the exam, as well as what sort of questions to expect and the levels that you would need to be able to answer. So what does question 5 cover? Well, question 5 is all trigonometry questions. So this comes with the expectation that you know how to do your trigonometry ratios with the right angle triangle. We talk about compound and identity triangle angles. We talk about double angles. And so you need to know all of this theory. What's really nice here is that your exam paper has a formula sheets at the back of it. And so if you get really stuck and you can't remember, I know that some students panic. And so you know that you have that as a backup. So go and take a look at that formula sheet before you write your exams and see what formulas are on there so that you know that those are the ones that you can rely on and count on. And the other ones that you might need, you would have to then learn off by heart. But at least that way you sort of have an idea of what your backup is in the exam. So it's jump right in. So it says, given sine beta is equal to 1/3, where beta is between 90 and 270 degrees, without using a calculator, what? No, just kidding. Determine each of the following. So it says, the first one is cos beta. So this is really just working out your ratios. Now we know that we've got sine, cos, and tan. Okay, don't worry, I'll erase this. But I always recommend when you start doing a trigonometry paper to write down your 3 ratios and then to use whatever rule that it is that you've learned. So SOHCAHTOA, or I like the rule U are excellent, are you excellent. Okay, so that's my rule that I learned when I was in matric. And so this will help you when you are doing questions like this. So firstly, we can see that cos is x over r, and we can see that sine is y over r. So we're missing the x, okay? And how do we find x in a triangle? Well, we know it's a right angle triangle, and it lies somewhere between these two Cartesian planes, okay? We can see y is positive, so it means it's going to be up here. Okay. So we've got that y is 1 and r is 3, and we need x. And how do we find any value in a right angle triangle? Well, we use Pythagoras. So we're going to have x squared plus y squared is equal to r squared. Okay? And so if we just substitute this in, x we don't know, and that's what we're looking for. Y is 1 and r is 3. And if we take it to the other side, 3 squared is 9, 1 squared is 1, and we take it to the other side, becomes minus 1. All right, and so x squared is equal to 8. Okay, but now we can see that it's in the negative side of the Cartesian plane, and so x is equal to negative square root 8, or equal to negative 2 square root 2. So just pop that into your calculator and it will simplify the third for you. Okay, so you're going to get a mark in this first part of this first question for this and a mark here for that. And your final answer of cos beta is just going to be x, which is negative 2 over square root 2, and your r, which we wrote down here, so that will be 3, and that is your final mark. So that's why it covers 3 marks. So the first question of a trig question like this will always have marks available for doing this calculation and working it out. Okay, so I hope you've made a note of these values, and I'm going to just erase this, all of these, so that we can work on sine 2 beta. Okay. So when we can see that sine 2 beta is a double angle. So the first thing that we need to do is simplify it. Okay, and so we know if we go look at our formula sheets, or we know it off by heart, we know that sine 2 beta is 2 sine beta cos beta. Okay, and this is a very good one to learn off by heart. It's pretty simple. It only has that one thing that it links to, so it's nice and easy to remember. And now we just fill in all the values. So we know sine beta is 1/3. It was given to us. And we've just found cos beta, which we saw was negative 2 square root 2 over 3. And now we just simplify. So we have 2 times 1 is 2 times negative 2 is negative 4 square root 2. And just remember this is over 1. So 1 times 3 is over 9. So that's our answer here. So again, you've got 3 marks for this. So your first mark is to actually write out the double angle rule. Your second is for substitution, and your third is for your final answer. So really nice, easy marks here. It's just knowing your theory and being able to apply it. All right, the final one says cos 450 degrees. Okay. So whenever we see something like this, we think about our cast diagram, and this is also super useful to write down as soon as you start your trigonometry question. You should always have a cast diagram at the top of your page to refer back to. Okay, it doesn't have to be big, just has to be there so you can see it and check. Okay, so 450 degrees is bigger than 360. So the first thing that I'm going to do is I'm just going to say 450 minus 360. And our magical calculator in the background tells us that it is 90. So when we have 450 minus 360, it basically means we've gone all the way around and back again into this positive quadrant here. So it doesn't change any signs. It just essentially reduces the angle to cos 90 minus beta. Now we can see this is a co-ratio. 90 minus or 270 minus or 90 plus or 270 plus are co-ratios, and that changes our cos to a sine. So that's going to be sine beta, and because it's 90 minus, it falls into this quadrant here, which is positive, and so it doesn't change our sign. And we all know sine beta, because it was given to us, is actually just 1/3. So again, if we're looking at our marks, you're going to get a mark for simplifying this ratio here, a mark for changing it into sine, and a mark for your final answer, which they already gave to us. So pretty straightforward there. Okay, so this is quite a nice question to get a lot of marks on. It's grade 10 maths. I mean, with a little bit of grade 11 and 12 thrown in there, but it's all theory. So if you learn your theory, it's easy to get marks here. All right, so the next question says, given you've got cos to the power of 4x plus sine squared x cos squared x over 1 plus sine x, and it says prove that this whole thing is equal to 1 minus sine x. Okay, so the way that we were taught it back when I was doing maths, dinosaur period, is, I'm just joking, I'm not that old. But the way that we were always taught it is to start with a more complicated one and simplify that. It's harder to make something more complicated, but it's easier to simplify a complicated mess. Not when it comes to women, but that's another story. Okay, so firstly, we can see that we can just take out a common cos squared x. Okay, so we're going to say left-hand side, okay, because it's on the left. I'm not going to rewrite it again, just because I'm going to run out of space. But when you do this in the exam, you should always have left-hand side equals and write down the original expression into your question paper. That helps you, and make sure that you don't make any mistakes here, because then your whole question is wrong. So be very careful about copying stuff across. Okay, it's very easy to make a mistake here when you're rushing and you're panicking. So take your time, make sure that you write it down correctly. Now, the first thing that I can see here is that I've got a cos to the 4x and a cos squared x. So I can take out a common cos squared x, right? And that's what I'm going to do. So I'm going to have cos squared x. And what I'm left with is just cos squared x, because cos squared times cos squared is cos to the power of 4. And here I'm going to be left with this one comes out, and I'm only left with sine squared x. Okay, all over 1 plus sine x. Okay, and what I can see immediately, and I know from my identities, is that cos squared x plus sine squared x is actually equal to 1. Okay, so then I can now write this as cos squared x, because the rest is simplified to 1, over 1 plus sine x. And I see I've written very badly. I left out the x there. Okay, now cos squared x is another identity, and it works with the same one, because cos squared plus sine squared is equal to 1, or cos squared is equal to 1, and I take the sine squared to the other side, it becomes 1 minus sine squared. So I'm actually going to change that into 1 minus sine squared x over 1 plus sine x, right? And do you see here Now they're starting to look very similar. And this here is a difference of squares. Okay, and so, sorry, I'm going to go this direction here. So what I have is 1 minus sine x and 1 plus sine x. This should feel very familiar. And of course, over 1 plus sine x. Okay, now we can see that we have a common factor that we can cancel. Okay, and we can only cancel when stuff is in brackets. So just remember that. You can't cancel if there's plus or minus sign and no brackets. You have to factorize it first. And so what we're left with at the end is 1 minus sine x. And therefore, left-hand side equals right-hand side. So we have proved it. Okay, so where do your 4 marks come from? The first one comes from the fact that we have identified that this is equal to 1, and it's done here. So 1 there. We have factorized it, so that's another mark there. Then we changed the cos squared x into 1 minus sine squared x, and then we get a mark for factorizing it. And because once we factorize it, we've essentially proved it. Okay, so pretty straightforward there. Remember again, if you want to look at my answer for longer, you can always pause the video to help you with make sure that you've got the right answer and you understand why everything happened the way it did. All right, so the next thing says, for what values of x in the interval x between 0 and 360 is this undefined? Now, whenever we get a question that asks us for something that is undefined, undefined should tell us that we are trying to divide something by 0, which we can't do, okay? And that's why it becomes undefined. So how do we divide anything by 0? We can see this is our divide line. And so we're trying to make this equal to 0. So 1 plus sine x is equal to 0. Now, I'm going to use my calculator for this, but there are multiple methods. I just find it easier just to grab it quickly, and I'll show you how to do it. So on your calculator, what you would do is go to your table mode, which is 2, and just type in your denominator, which is 1 plus sine x. So 1 plus sine, and to make an x, just RCL twice, and then equals, ignore function 2, we don't need it, start at 0. I'm going to make steps of 15. That should give us a good answer. And now if I scroll through the table, I'm looking for where my answer is 0, and they gave it to us between 0 and 360. So I can start at 0, and I'm just going to go scroll. I'm going to look for where my answer is 0. And the only place I find it is at 270. The rest is all positive. Yes. So here we can see from this that the only place where x is undefined is actually at 270. So we would just then say x is equal to 270 degrees. Okay, so of course you need to write down 1 plus sine x is equal to 0 to show that you understand what's going on, and then write down your solution. So you get 1 mark for that one and 1 mark for that. So showing that I understand and then giving the actual answer. Okay, the next question says write down the minimum value of the function defined by, and then you've got cos 4x plus sine squared x cos squared x. So it's the entire thing again. Okay, and we know that it is equivalent to 1 minus sine x, because we proved that in 5.2.1, right? So we can use that information, and we're going to, again, just go chuck this in the table, 1 minus sine x. So here we go. And I've already got 1 plus, so I'm going to be super lazy and just delete the plus and change it into a minus, equals, 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 equals. And now I'm looking for the minimum, the smallest possible value. So between 0 and 360, what is my smallest possible value? So let's go look. So it's getting smaller, 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 0. And then it goes positive again, positive, more. And so my minimum value, if I continue looking, is again always 0. So here we can just write minimum is 0, and you will get 2 marks for that. You don't even have to prove anything else, just to find that that is 0. Okay. Now it says, given cos A minus B is equal to cos A cos B plus sine A sine B. So this is one of the theories that we learn with compound angles. And now we need to prove the sine A minus B formula. Okay, and we use co-ratios to do that. Okay, so what we're going to do is we're going to say cos of 90 minus A minus B. Okay, so in other words, if I did this, okay, then the negatives, etc., go in. I just want to erase that so I don't confuse you. Cool. All right, so now we put this into our formula here. Okay, so we're going to have cos, and what we're going to do is group it with 90 minus A, and then the second one with negative B. So it's going to be cos 90 minus A cos negative beta, or B, and then plus sine 90 minus A sine negative B. Okay, and then we just reduce it. Okay, so here we can see cos 90 minus means that it is actually sine, and so we'll have sine of A minus B, right? Okay, now, again, remember our cast diagram. It's always good to have it wherever you are working. Okay, so cos 90 minus is in this quadrant, so it's going to be positive. So it's just going to change it into sine A. Now cos negative B goes here, and that's cos, so it's positive, so it just stays cos B. Okay, very cool. I'm going to leave the sign out for now. I'm just going to make a blank so that we remember to fill it in. Sine 90 minus A is again in the first quadrant and it's positive, so it's just going to be cos A. And then sine negative beta is here, but that would make sine negative. So here it's a positive, and here this thing is a negative. So negative times positive is a negative, and then it will just be sine B. Okay, and that's simplified, and we are all done. So where do our marks come from? Right, there are 3 marks. So the first one is to do this, where we add that 90 minus, do the co-ratio, then to fill in the compound angle as we did over here, and then, of course, to simplify and do the reduction. That's your 3rd mark. Pretty straightforward, right? It's using your theory. So again, knowing your co-angles and your cos and your sine relate to each other, and then just substitution and process. Okay. Now it says 5.3.2, hence or otherwise, determine the general solution of the equation. So when they say hence, they're saying use the previous solution to find the new solution. That's generally the suggestion that they're making. Okay, and we can see that this is a sine, cos, sine, which is what we used over here, right? You see this one here. So we can use the same thing to reduce it back to sine, and that's what we're going to do now. Okay, so we've got sine 48 cos x. So what it's going to become is sine 48 minus x is equal to cos 2x. Whoopsie. Okay. But now we've got a sine on one side and a cos on the other, and we can't actually change anything about it. So the next step is now to change one of these two things into either a sine or a cos. So I'm going to change this into a cos. So that's going to be cos 90 minus 48 minus x is equal to cos 2x. Now, because my trig ratios are the same, the cos and the cos, I can drop them. Essentially, I don't need to work with them anymore. And so what I have is 90 minus 48, which is 42 degrees, plus x is equal to 2x. Okay. So up until that point, it's pretty straightforward. But now they've asked us for a general solution. So a general solution means that we want to give an idea of when this will work on the graph, or when they will be equal to each other on the graph all the time. Okay, and so we want to create a general equation of this. Okay, and again, we're going to use our cast diagram. All right. Now, because we've used cos, we're looking at where is cos positive, and it's in these two quadrants. Okay, so we're going to get x by itself. So we're going to have 42 plus x is equal to 2x plus 360 degrees. That's for this quadrant here, okay? Okay, so on this side, then we're going to have 42 plus x is equal to 360 minus 2x plus k360, right? And again, sorry, there should also be a k360 there. Okay, so that's your general solution. And now we're just going to simplify it. Okay, so bring the x to the other side, becomes negative x, because x minus 2x is negative x. And then it will become minus 42 plus k360. And then we divide by a negative or multiply by a negative, whatever makes you happy, negative k360. Okay, so that's the one general solution. And on this side, we'll take the 42 to the other side and bring the 2x this side. So x plus 2x becomes 3x and 360 minus 42 plus k360. Okay, so that is a magical calculator in the background, gives us 318 degrees plus k360. But you can't have 3x here, so we need to divide by 3, and so everything gets divided by 3. So this thing, magical calculator in the background, is 106 degrees plus k120 degrees. Okay, so marks here for this solution. You're going to have 1 mark for doing the compound angle thing, and the co-ratio and breaking it down. Okay, sorry, there's a compound angle, there's your co-ratio. And then you'll have a mark for writing out both of these equations. Okay, and then you'll have a mark for that solution and a mark for that solution. So quite a lot of work needs to go into here in order to achieve good results. Okay. The final question says, simplify sine 3x plus sine x over cos 2x plus 1 to a single trigonometric ratio. So again, this is just about knowing our theory. Okay, and so sine 3x we can break down into sine of 2x plus x, right? Plus sine x. Okay, over, and then that's just cos 2x plus 1. Okay, so this one we'll use as a compound angle. Okay, so if we follow the rule that we used in 5.3.1, we'll have sine 2x cos x, right? Plus cos 2x sine x plus sine x. All over. And now cos 2x, there are 3 different things that the formula sheet gives us. And the one that I'm going to use is actually going to be the one that gets rid of a 1. So I'm going to use the 2 cos squared x. Okay, and so I'll write 2 cos squared x minus 1. That's my cos 2x plus 1 here. Okay. The next step is to then take out the 2's, so to get rid of those double angles. So I'll have 2 sine x cos x, that's for this one here. And then I've got a cos x attached to it, so times another cos x plus, and now I've got cos 2x. So here what I'm going to do is I'm going to use the same ratio or the same double angle identity, so 2 cos squared x minus 1, and it's being multiplied by sine x, so I'll just add the sine x to the back. And then I've just got this random little tag along sine x, which I'm not going to do anything with yet, all over. Now minus 1 plus 1 goes away, so I'm just left with 2 cos squared x minus 1. And I see I've written like a bit of a nana. So I'm going to have to erase all of this. So just make sure you've got it, or pause the video to write it down, and then we'll continue. So let me just erase this and we'll continue from the top. So what we do then is we multiply out, okay? And so we'll have 2 sine x And then cos times cos becomes cos squared x. All right. And then we've got the 2 cos squared x times sine x. So that we'll just have that here. 2, oopsie, cos squared x times sine x. And then we've got minus 1 times sine x. So it just becomes minus sine x. And we've got that random tag along sine x at the back, which we can now see will actually disappear. All over 2 cos squared x. Okay. So these two disappear. Well, they delete each other, so that's fine. And then here you can see we've got a common factor of 2 cos squared x, right? So we'll take, in fact, no, we can just add the two of them together because they are identical. So in fact, we'll have 4, because 2 plus 2 is 4, cos squared x, just in a different order. Do you see it's ab squared, and this one is a b squared a. Same thing, just a different order, but when we multiply, order doesn't matter. Over 2 cos squared x. All right. So here we can cancel because now we've got one term over one term. They are all factors. We can cancel out the cos squareds, and 4 divided by 2 is 2, and we're just left with 2 sine x as our final answer. Now you can see it's 6 marks, so you've done quite a lot of work in terms of theory. Okay, so your first marks will be with the first section that we did, where you expanded the 3x into 2x plus x, and where you simplified your cos squared double angle. Then you got a mark for expanding that sine 2x value and cos 2x value. And then using your identities with the double angle, then simplifying, then your common factor mark, and then your final solution. All right. So that is question 5. I hope you found this part of the trigonometry question helpful. Remember, in question 6, we'll be looking at trigonometry graphs. Fun. So join us for the next one. And remember that if you're stuck, you can go and download worksheets and past exam papers to practice with, as well as study guides off Maths at Sharp. Good luck for your finals, guys.